Sample problem number 11 and 12. So for sample number 11 and 12, this is about evaluating limits. So for number 11, so instead of using the solution here, the disadvantage of using this one is you must be good at factoring. So when you have difficulty in factoring, just use L'Hospital's rule. So when the given is in quotient form, use the L'Hospital's rule. So all you have to do is just to differentiate the denominator and the numerator. So the derivative of the numerator, x cubed minus 14x plus 15, is just 3x squared minus 14. So by what I say, derive it individually, not as a whole function. So otherwise we will use the quotient rule, but we will just derive separately. So derive the denominator, so that's why we have 3x squared minus 13. And then once you are done deriving, you can substitute now for the values of x, which is 3. So when you substitute 3 times 3 here, squared minus 14, the result is 13. So 3 times 3 squared minus 13, the result is 14. So it's a shortcut. For number 12, so we will still use the L'Hospital's rule. So the derivative of the numerator, so the derivative of cos is negative sign. So we already have a negative sign, so the negative of the negative is positive. So we have cos is positive sine x, and then the derivative of x squared is 2x. So when we substitute x equals to 0, the whole equation will become 0 over 0. So this will become undefined. So if that is the case, you differentiate it again. So the derivative of positive sign is cosine. The derivative of 2x is 2. So we will try to substitute 0. So cosine of 0 is 1, and then divided by 2. So now it's okay. So just apply L'Hospital's rule. So sample problem number 13. So for sample problem number 13, this is an application of finding the slope of a curve. So the slope of the curve is the straight line that is normal, the slope of the straight than tangent line at that particular point. So we are given with a circle x squared plus y squared is equal to 25, and then we wanted to find the slope at negative 3, 4. So if we are going to draw the figure, so we have a circle, so this is x squared plus y squared is equal to 25, a radius of 5, as you can see, and then the point negative 3, 4 is in the second quadrant. So what is the slope of this tangent line? So that is what we meant by the slope. So for this type of problem, all we have to do is to find y prime, and then substitute the value of x, which is negative 3, 4, and then y, which is 4. So we will differentiate this equation, apply implicit differentiation. So the derivative of x squared is 2x, the derivative of y squared is 2y. Since there is still y, so we need to differentiate that, so that's why 2y y prime, and then the derivative of 25 is 0. So rearrange and solve for y prime, so y prime is negative x over y. Then substitute the value of x and y at that point, so that's why we have negative of negative 3, 4, so the answer is 3, 4. So the slope is positive 3 over 4. So the answer is correct because the line is increasing from left to right. So for the tangent and normal line, so this is the equation of the tangent line, and this is the equation of the normal line. So for the tangent line, we will need to find the slope, and then for the normal line, the inverse reciprocal of the slope. So sample problem number 14. Find the equation of the tangent and normal to the curve xy is equals to 4 at 1, 4 at the point 1, 4. So drawing that equation, this is actually this is a hyperbola. So as you can see, that is the graph of the function, and then we wanted to find the equation of the tangent line and then the equation of the normal line at this point 1, 4. So we will perform first differentiation to solve for y prime. So differentiate this, so this will become xy prime plus y. So this is product rule. Derivative of 4 is 0. Then resolve for y prime, so the result is negative y over x. So we will substitute the value of x and y, which is 1 and 4, so that we can solve the value of the slope. So substituting x and y, so that's why negative y over 1. So the slope is negative 4. And then we will go back to our equation, the template. So this is the template for the tangent line, and this is the template for the normal line. Just substitute all the values. So our y(O) is our given y. Our y prime O is the slope, so that's why negative 4. And our xO is our given x. So that's why we have this one, and then just rearrange so that our equation will be in standard form. The same also for the normal line. It's just that the difference now we have inverse reciprocal as a slope. So that's why we have inverse reciprocal of negative 4. It's of course positive 4, but the inverse of positive 4 is positive 1/4. So negative 1 over negative 4 is positive 1/4. And then rearranging so that we will have a standard form. So that's why we have this equation. So that's why we have the equation of the normal line and then the equation of the tangent line at the point 1, 4.